Hello. If everybody could please find a seat at one of the tables, we'll get started. Thank you. Okay, great. Well, welcome to the 5th annual LaunchCMU Silicon Valley. Welcome, everybody. This is the 5th year that we've done it, and this got started with the generosity of Latham and Watkins. Patrick, Pollan, Ben Potter are here today. You'll get to meet them. And we've been doing the event here at Oracle for 4 years right now. So we're very excited about this. Today's theme is robotics in manufacturing, but there are other companies around the edges of the venue here today that are not robotics. They represent all of the different kinds of technologies and companies that come out of Carnegie Mellon. So hopefully you'll get a chance to tarry and talk and meet those folks. When we were last here doing this event, we were known as the Center for Innovation and Entrepreneurship. This past year, we relaunched as the Swartz Center for Entrepreneurship after a transformational $31 million gift from Jim Swartz, the founder of Accel Partners and a 1966 Carnegie Mellon Tepper alum. What I thought it would do is show you the video that we showed last fall at the formal launch at LaunchCMU back in Pittsburgh. So without further ado, this is what the Swartz Center does.
Opportunity. It's out there. Through creativity, hard work, and soaring above the norm, you can seize it. You are an entrepreneur. Whether you're an undergrad, a graduate student, an alumnus, or a faculty member. The Swartz Center for Entrepreneurship at Carnegie Mellon University is your opportunity, your path to success, where you bring your ideas to market. Courses for credit at Carnegie Mellon are at the core of the ecosystem, supported by countless extracurricular programs, global resources, and networks that launch companies. Entrepreneurs jump into the Swartz Center ecosystem at any time to build a unique path and collide with ideas, creativity, and visionaries also striving for success. Consider a student. While attending Entrepreneurship Bootcamp, he learns about the Swartz Center Incubator, Project Olympus, giving him the opportunity to earn a Spark grant, which provides the capital needed to launch his startup. He then becomes a Swartz Fellow, a cohort program for entrepreneur training. Or a faculty member who, through the National Science Foundation I-Corps program, discovers how to commercialize her research, which then gains recognition at LaunchCMU, the Swartz Center's public entrepreneur showcase of student, alumni, faculty, and staff. At the same time, her PhD student earns additional funding by winning the McGinnis Venture Competition for CMU students and becomes an Innovation Fellow. An alum takes full advantage of the Swartz Center Connects workshops and gets mentoring from the entrepreneur in residence who suggests joining the I-Corps Site program. During this program, the alum learns about the Open Field Entrepreneurs Fund, which provides seed funding to recent alumni. For every entrepreneur, every research project, every business idea, our centralized ecosystem creates unique paths to learn, network, commercialize, invest, and launch the next great startup.
The Swartz Center is a great place because with all the resources at Carnegie Mellon, it's all being put under one roof, and that's amazing.
The quality programs at Carnegie Mellon, it's the people, it's the fact they interact with each other, it's the fact that there is this more community spirit here that's really important and really helpful in starting businesses.
Students and faculty are really able to come together and share their thoughts and opinions and experiences regarding entrepreneurship. Different seminars that were free and open to anyone on campus was incredibly helpful to me.
Everybody has an extracurricular activity that they enjoy and that they're really passionate about, and they sort of combine their passion with their major, and that is exactly what is necessary to be a successful entrepreneur.
The Swartz Center for Entrepreneurship at Carnegie Mellon University.
It's great. My name's Dave Mawhinney, and I'm the Executive Director of the Swartz Center for Entrepreneurship, and I'm also a faculty member at the Tepper School of Business, where I'm a professor of entrepreneurship. We've built a great ecosystem at Carnegie Mellon over the past decade, starting with Project Olympus, which was founded in the mid-2000s, partnering up with the Don Jones Center for Entrepreneurship in 2012 to form the CIE, and now we're taking it to the next level. Okay, we're not getting it to move. Let's try that. There we go. We have the same goals that we had with the Center for Innovation and Entrepreneurship. That's to make Carnegie Mellon the #1 entrepreneurship school in the world. As I always say, and pardon my French, and for those of you that went to the Voldemort schools of Stanford and MIT, we want to kick your butt. We want to create valuable companies coming out of CMU, and that's why we're doing events like this, to introduce them to the investment community out here in Silicon Valley, in the Bay Area, and to connect with our entrepreneurial alums that are out here, breaking the mold and creating really valuable companies here. Later today, you'll hear about a program called the Venture Bridge that's in partnership with the Integrated Innovation Institute that we're taking more full advantage of the resources that are out here in Silicon Valley. We also want to activate our 100,000 strong entrepreneurial network. That's all of you in the audience that went to CMU. As I've always said, we want you to be a customer or a supplier or a mentor or an investor in CMU companies, and that's the purpose of this event today, so that you can find one of those companies that catches your eye and help them along their journey. We are doing some new things with the Swartz Center, and I wanted to point them out. One of the things is upping our expertise at the university. We have a new program called Entrepreneurs in Residence. We have 3 of them here with us today. If Will, Craig, and Robbie can stand up, I'd appreciate it. There's Robbie, there's Will and Craig. Craig Markovitz is the founder of Blue Belt Technologies, which he sold last year to Smith & Nephew. Will Kegler created a company called MedSage Technologies, and he sold that to Philips Respironics. Robbie is running our Venture Bridge program out here. We have 2 other entrepreneurs in residence, Rob Meyer, who recently sold No Wait to Yelp, and Kit Needham, who's also the director of our Project Olympus incubator back in Pittsburgh. So not only are we upping the ante by having real successful entrepreneurs on campus working with our entrepreneurs, but we're reaching out to our alumni who can be mentors or come back and do talks. We have a series called the Connect series that we run 3 or 4 seminars every week to help the next generation of entrepreneurs. And we would love you all to get involved in that and talk about what you're experts in. We're looking to create more funding opportunities for startups. Obviously, this event does that. Our Open Fields Entrepreneurs Fund does that. There's a lot of investors who have not been at this event before that are here today. So we are picking up some momentum in that area. We want to create bridges to where our alumni are. Pittsburgh is the #1 density of alumni for Carnegie Mellon, but the Bay Area is #2, and New York City is #3. So we're starting with the Venture Bridge in partnership with the Integrated Innovation Institute here to take more full advantage and make a portal, a gateway for anybody connected to CMU to come take advantage of what's happening here in Silicon Valley. And we're creating new academic opportunities. We have a new campus-wide minor called Ideate that includes engineering, computer science, design, and business classes. You're going to hear about the new Masters of Science and Technology ventures today that's being run by the Integrated Innovation Institute as well. So lots of new things that are happening at Carnegie Mellon, and we hope that you will pitch in with us. One of the more exciting things is $10 million of the $31 million that Jim Swartz has given us is going into the new Tepper Quad, which is in the new physical center of campus. It's right across Forbes Avenue from where the Heinz School is, old Hamburg Hall, for those of you that remember. It's going to transform what Forbes Avenue looks like and really be an enhancement for the university. When you walk in the front door of the new Tepper Quad, the Swartz Center will be right up on the right. And it's meant to highlight what's always been special about Carnegie Mellon, which is the interdisciplinary collaboration, right? The hacker, hustler, designer model of teams for entrepreneurial ventures. We'll have an 8,000 square foot or palette that'll look like the typical accelerators. The rooms around the edges are garages to sort of metaphorically symbolize starting your companies in the garage. We will have lots of events there, so we hope that you will come back to Carnegie Mellon and visit us at the Swartz Center. I'm going to move on to the rest of the program because we have a lot to cover today and I want you to meet a lot of different people. But before I do that, I want to thank a very special person, Michelle Kovac, who's been our partner here at Oracle. Michelle, you're in the back. Wave to everybody. Give her a great big hand. Without her, this event could not happen. Whoops, I hit too many buttons. While the people in the back fix what I just broke, I'm going to introduce Craig Stephen. Craig is a Carnegie Mellon alum. I don't remember which year, Craig, but I'm sure you'll tell everybody. But Craig has probably one of the very best jobs here at Oracle. He's the Senior Vice President of all Research and Development, and he runs the Oracle Lab. So let's give Craig a great big welcome.
Thank you, Dave. Thanks. I'll take this microphone off here. Let's see if that's going to work. Probably piss off the AV staff, but that's okay. Yes, my name is Craig Stephan. I'm Senior Vice President of Research and Development at Oracle. Now, Oracle's like jam-packed with Senior Vice Presidents of development things. I don't run all of development at Oracle. I'm the guy with the R, the research in the title. So I'll come back to that in a second. I'm super happy to welcome you all to Oracle for this fourth instance of LaunchCMU here on Oracle's campus. It's super exciting. I wanted to talk a little bit about what's the connection? I mean, why Oracle and CMU? I mean, there's no Oracle building on campus next to the Gate Center, like hidden down the hill behind there. Not even like an office, like in the third sub-basement of Downey Hall or anything like that. What's the Oracle connection? Well, it's called people. Hundreds and hundreds of people. For example, some guy named Ray Lane, former Oracle executive on the board at Carnegie Mellon. Keith Block, also former Oracle executive. And hundreds of other examples like me. I started at CMU in 1984, undergraduate. Unlike many of you in the room, I'm not didn't study robotics or manufacturing. I studied applied math. There was no undergraduate degree for computer science back then, so I studied math. And but there were robots on campus. In fact, Mark Reiwert had done his famous hopping robot leg lab work that was a little before my time at Carnegie Mellon. He's, in case you don't know the name, founder of Boston Robotics, Boston Dynamics, excuse me. But in my time, there was a robot lab. You go in there and see the robot with these little sensors on it and so on. But my favorite example of a CMU robot was I was walking to class one day on the cut in between Lee Hall and Baker Hall. And there's this like filing cabinet on wheels just sitting there. It's just sitting there. And I'm on my way to, okay, whatever. Go to class, come back an hour later. It's still there, but it's moved like about 20 feet. So, wow, cool. This thing's like a video camera's on it. Wow, it's some kind of self-driving robot thing. Like maybe someday we'll have self-driving cars, but man, they're going to be really slow. So, at any rate, I learned later that this DARPA-funded particular self-driving robot project, it had at one point mistaken a tree for the edge of the path that it was supposed to follow, and was trying to climb up the tree. So just keep that in mind next time you're about to get in that self-driving Uber on your way out from campus. So anyway, I mean, people talk about how the robot revolution and self-driving cars, it's all come upon us so suddenly. It's like, come on, it's been 30 years since that. I mean, like, what's taking you guys so long? So at any rate, I graduated from CMU in '88, came here to Oracle, and quickly discovered that this place is positively infested with CMU graduates. My boss, Edward Screven, our chief corporate architect, CMU guy. I will say CMU graduate. Larry Ellison convinced him to skip all that graduation nonsense and come out here to Oracle and work for him a long time ago. Fast forward about 25 years, we bought this company called Sun Microsystems. Kosler, CMU guy, and Sun, CMU guy, entrepreneurs like you. I became responsible for what was then called Sun Labs, which we now call Oracle Labs, which was when Sun acquired Sun Labs, it was this entity called Sutherland Sproul, founded by Ivan Sutherland, father of computer graphics, and CMU graduate, actually Carnegie Institute of Technology graduate, 50s sometime, and Bob Sproul, CMU professor in the 1980s. The labs was co-run by Sproul and another guy named Jim Mitchell, PhD, CMU in the 70s on compilers. So my whole ecosystem here at work, where I come every day, is basically a CMU ecosystem. One of my other responsibilities, though, is mergers and acquisitions, running technical due diligence for acquisitions. I've worked on maybe 130, 140 deals in my career at Oracle since the late 80s. And I get to see kind of a view of you all, except through a different filter, maybe with some survivor bias added to it, and a little bias towards people who chose like an acquisition exit for their business plans. And I think there's a deeper sense beyond just people that makes CMU and Oracle and you all kind of connected, and that's this bias towards pragmatism. At CMU, it all struck me even as an undergraduate that all that theory is great, but what are you going to do with it? And here at Oracle, we have the same sense. Every developer, you understand, the point is add value for shareholders. Get out in front of customers, figure out what they want. And when we do diligence for acquisitions, we're like archaeologists. We're digging through the layers and finding out kind of what happened. And in some, significant percentage of the cases, it becomes very clear that the business we bought that is so compelling that we need to own it here at Oracle, that's not the business the entrepreneur started. Okay? Far be it from me to give you guys advice, entrepreneurs, people who are like trying to make the payroll at the same time as raising your next round, and also delivering product and all of it on no sleep. I can't pretend to understand what you know and what you're going through, but keep your mind open and keep that outsider spirit, because just like Andy Grove and Gordon Moore at Intel, when they were trying to struggle with whether to exit the memory business or not, having that perspective of what would the outsider do, that could lead to a revelation that changes where you're going in such a way that you become Oracle's next acquisition. So I'll leave you with one last thought from Larry Ellison. I'm going to have to paraphrase it. I don't think this one is made it on the web. It's something he said internally here at Oracle years ago, and it kind of stuck with a lot of us, which was more or less, if you're not building product or selling product, what the heck are you doing? So go out there, build and sell, and I hope to see you at the end of your journey. Thank you. Thank you.
Just a brief reminder to the rest of our speakers, if you could stay at the podium because we are videoing this, it'll make it easier to keep you in focus. It's his house, he can do whatever the heck he wants, right? As I mentioned before, this is our 5th year of doing LaunchCMU, and it's grown every year, and it's thanks to the investors and the alumni that come. So thank you very much for doing that. But this has been done in partnership with Latham & Watkins. I mentioned Patrick Pollan and Ben Potter before. They work with a lot of really great Carnegie Mellon companies. They're outside counsel for Duolingo, for Solvi, which is a really cool up-and-coming machine learning AI technology here in the Valley, and countless more. So without further ado, I'd like to invite to the stage Patrick Pollan, who is the partner and global co-chair of the Emerging Practices Group. Let's give Patrick a big hand.
All right, I'm going to be a lot more brief than the first two. Dave told me I couldn't have any slides anyway. So I'm Patrick Pollan. I'm a partner at Latham. I head up our tech practice worldwide. My partner, Ben Potter's here. We've worked together for the better part of a decade. What we do in our practice group is we work with startups and venture capitalists. And we've been involved with this event and with CMU since this event began. And it's a terrific event. We're honored to be part of it. And with that, I just want to say thank you to CMU and to Oracle for hosting. Thanks.
Thank you, Patrick, and your support has been truly meaningful for us, and we could not have done it without you. So we mentioned earlier this new program that's partnering with the Swartz Center called the Venture Bridge. It was initiated by the Integrated Innovation Institute out here in the Silicon Valley campus, and it's been brought into the Swartz Center family and fold. We're very excited about this because our entrepreneurial programs at CMU have never fully leveraged the value that's out here in Silicon Valley, and this program is going to allow us to do that. I'm going to ask Robbie Thomas, who is the director of the Venture Bridge here in Silicon Valley and an entrepreneur in residence, to join us and tell us a little bit about the Venture Bridge.
Thank you, Dave. This is the clicker? I'm sorry. Yeah. As Dave mentioned, we had over this, I sort of back up a little bit. I teach in the software management and technology ventures, the new technology ventures program. And we've always got our existing students have been demanding some kind of help in terms of taking their ideas, the business ideas that they have, into some concepts which could get funded either from venture capitalists or allow them to enter accelerators, et cetera. So that was been the motivation of the program. And we ran a pilot program in 2015. Okay, so I'll talk about the thing. So recently, it's important that we felt the need to kind of, is that clicker? Green button. The green button? Sorry. Okay, so we saw that, we saw the transformation of the entrepreneurship thing under the Swartz umbrella in Pittsburgh. So we wanted to make sure that we had there would be an initiative in the valley where there would be a Swartz Center initiative in the valley. So what we basically took is what our pilot program that we ran in 2015 into a semester-long pre-accelerator for CMU students, both Pittsburgh and Silicon Valley, and alumni to develop viable ideas into sort of the business concepts. And really, it's to position the teams to enter accelerators, to get to pitch to angel investors, get seed money, et cetera. So the focus is early stage companies, pre-seed and seed stage companies. The primary focus is our CMU students, undergraduates, graduate students, PhD students, and also our postdoctoral researchers. Our secondary focus is on the CMU alumni who are CMU, I should really say the Bay Area alumni of CMU, who wanted sort of a home in the sense of to take their ideas, access the networks that's the CMU networks that we have here. And so if you just have to look around here, all the entrepreneurs, the investors, and the alumni who all have CMU's DNA in some sense. So that's our primary focus, is to involve the CMU alumni in the process. Okay. Just to give you a flavor of the applications and where the teams are coming from. Our teams come from our Masters in Software Management program. Eventually, we expect teams from our Technology Ventures programs to apply into the Venture Bridge program. We have TEPR and CS, Computer Science programs, Pittsburgh teams, and we have alumni teams. So we have all of those teams. And surprisingly, we have a lot of alumni teams applying for our Venture Bridge program. So it provides them a way to get back to their kind of CMU home, but it happens to be in Silicon Valley. The benefits are the teams, I admitted, will have access to myself, which is an entrepreneur in residence. I've been in the startup business since '96, so it tells you my age. And I've been through all the ups and downs of the startups in terms of funding, up rounds, down rounds, sideways, everything. So I've been through about 4 startups, with reasonable exits. So that's my background, and I've been teaching in the III program. we are getting a team together in terms of faculty and alumni mentors. We provide co-desk working space, maker space in tech shop, and the best thing is it's equity free. Okay. Now, what about the financial resources? We can't, what we would like to be is, we would like to have about 10 teams go through a program every semester. Well, it can't all be from Silicon Valley, so there has to be teams from Pittsburgh. So we want to make sure that we raise money so that we can provide resources for Pittsburgh. Bay Area is a pretty expensive place to live in. So really, in terms of stipends. We also want to be able to provide our teams customer discovery grants and maker grants. We are seeking funding from our very generous alumni donors, VCs and companies, and please come by our table if you want to sign up for that particular component of it. Now, I just want to mention an early success story, which is right in that corner, Exeer, which kind of went through the sequence that we expect our teams to go through. They spent the summer in the Venture Bridge program. In 2016, they entered they got a fellowship from Lightspeed Venture Partners. In 2017, they have funding. Okay, so this is really the path what we expect our successful companies to go through. Well, a high percentage would fail, but we want them to fail fast, and we want that's the process. We want to have we've got lots of very smart people, but they have to go through this particular process. I do want to invite everybody here to the first summer event that we are going to have, which is on August 3rd, which is an iCatalyst event where we are going to take the opportunity to welcome, look at presentations from companies across the US, but mainly it is to sort of celebrate our little CMU team called Forest Devices, which was the winner of the Rice Business Plan competition, and I think they got about $800,000 worth of funding from that business plan competition. We will also have a poster session with our 2017 Venture Bridge teams. Finally, my contact information is there. Please drop by our table. Okay, thank you.
Thank you, Ravi. Great job. All right, so I'm going to invite one young alum up on the stage because we had too many old dudes up here. This young man, Will Sanders, is an amazing guy. He's been very entrepreneurial. He has put together a series of events out here for our entrepreneurial alums over the last year and a half that have just grown and grown and grown. We're so happy to have him as part of the Swartz Center team and working with the Venture Bridge that's out there. So if we can all give a round of applause for Will Sanders, who's in product and operation at a stealth startup called Tectus Corporation.
Thank you, Dave. I just want to say a few words about some of the stuff I've been doing in the Bay Area. I've seen some familiar faces, but not too many out there. So if you haven't heard about my events or seen them, come talk to me after. Or email Dave, of course, and he can pass along email, but don't want to send too many emails, of course. So my background, I graduated from Carnegie Mellon, studied economics, graduated in 2014. Since then, I've worked at startups, but I've really noticed in the Bay Area that there weren't many events for other people interested in startups or entrepreneurship, or even tech for Carnegie Mellon, which I thought was a little ridiculous. So since then, I've started planning events that have been mostly in San Francisco, where I find featured alumni. At the last event, Eric Daimler, who I saw somewhere around here, was at the last event. So basically try to have featured alumni just to put a face that there are entrepreneurs in the Bay Area, make sure that it is visible in a networking opportunity for other people that are interested. So usually, around anywhere from 40 to 100 alumni attend. But really, the key thing is just building community and getting involvement. So I'm looking forward to working with Dave, the rest of the Swartz fellow, or the Swartz team. And if anyone has any questions, just feel free to talk to me after, or my email is williamleesanders@gmail.com, kind of quick. But if anyone wants to see me, I'm sitting back there. But I'll let the presentation get started since we have quite a few of them, so we can stay on schedule. Thank you.
Hello, everyone. Good afternoon. Good afternoon. Hi. Okay, I'm Lenore Blum, faculty co-director of the Swartz Center for Entrepreneurship. I'm very happy to see so many of our alumni and friends here today. Let me add my welcome to all of you. I would also like to especially thank again our sponsors, Latham & Watkins and Oracle. So thank you again. At Carnegie Mellon, I wear many hats. One is Professor of Computer Science, and I'm excited that a number of our companies you will hear from today are spin-offs of the Robotics Institute of the School of Computer Science. I'm also founding director of Project Olympus, our Pittsburgh campus incubator program, and so I'm really excited to join forces with Ravi Thomas from the Silicon Valley campus and the new Silicon Valley Venture Bridge you just heard about. Olympus has been catalytic for the booming Pittsburgh high-tech economy, which is receiving a lot of buzz these days. In fact, since its inception, Olympus startups have received over $300 million in follow-on funding, not coming to the center, but to the startups themselves, and not including 11 acquisitions. And many SBIR grants, which I'm very happy to say, about half of which have women in the lead roles. I'm also founder of the Women at SCS program in the School of Computer Science, and so it makes me particularly excited to let you know that this year, 49% of our new computer science majors at Carnegie Mellon are women. And this is up a notch from last year, so here we are. So you can imagine, I was somewhat surprised coming from the School of Computer Science, where women are now so rarely a minority in anything we do, that out here at this event, we are once again the exception. I think I speak for all of us and for the School of Computer Science when I say we are determined to lead change here, not just in Pittsburgh, but across the industry. And I would like to invite that after we have this presentations, that anybody who would like to help me work on generating and form a group of women in high-tech entrepreneurship, please meet me outside this room, and we can start to organize and really help to make change happen. So please join me, women or men, anybody who would like to help. And we also have a youngster here who I think will be really part of the next generation. So thank you very much. Okay, now I'm going to introduce the main part of the program. I am, first of all, very pleased to introduce an outstanding roster of speakers and companies, starting with my colleague and Swartz Center faculty co-director, John Kagan, who also wears many hats. John, where are you? Okay, John is George Tolman and Florence Barrett Ladd Professor in Engineering in the Department of Mechanical Engineering. He's also Associate Dean, College of Engineering, and co-director of the Integrated Innovation Institute. So you can see Carnegie Mellon works us all to the bone. John's research focuses on design methods, theory, and practice, including computational synthesis, cognitive-based design, and interdisciplinary product development. His other area of focus is in user-centered design and integrated product development practice. John's work has evolved from a synergistic relationship with industry, having worked with a variety of small and large companies, including Apple, HP, Procter & Gamble, Respironics, Alcoa, General Motors, Whirlpool, Red Zone Robotics, and Bayer Material Science, among others. When do you have time to teach? John. He has also served as an expert witness for intellectual property litigation. John will tell us about ARM, the new Advanced Robotics Manufacturing Institute at Carnegie Mellon. Welcome, my colleague, John.
Hello, everyone. It's great to see such a large group, and I actually want to thank really Lenore and Dave for building everything that is around us. Without them, we wouldn't have the entrepreneurial activities that we have at Carnegie Mellon. So I personally, as a faculty member and now administrator, appreciate everything they've done, and I'm honored to be able to be involved with them. So I have multiple hats, as Lenore said, and the hat that I'm here with today, right now, is as Associate Dean for the College of Engineering. I'm actually not involved with ARM, but I wanted to talk to you about that because I think it's a really exciting initiative that has been led by Carnegie Mellon, and it's because of that that we're presenting it to you today, and many of you, I think, will be interested. And once again, I have to figure out, I guess, the big green button, right, Dave? All right, so ARM is the Advanced Robotics for Manufacturing Institute, and it's an institute that's goal is to lead the creation of opportunities in U.S. manufacturing for productivity and growth through innovations and education in the robotics and general automation area. Otherwise said, it's an independent corporation led by CMU that leverages Pittsburgh's robotic coolness. So it's a very interesting and exciting opportunity, and for many of you, whether you're VCs or whether you're large companies or whether you're startups, this is something that if you're interested in this space, you should be a part of. So the mission of ARM is to, again, assert U.S. leadership in advanced manufacturing. And part of that approach is to lower the technical and operational and economic barriers for companies to adopt robotic technologies. A lot of the focus is on creating IP. And as I'll mention to you later, people own their own IP, but everybody who's a member is able to license that IP. Part of it is also to empower American workers to be cost competitive with low-wage competitors abroad, and also to aid in the creation and the sustenance of valuable new jobs in the U.S. So you can see on this map a lot of dots, which I'm not going to go into, but these are all the different members of ARM right now. And what's interesting is it's a combination of industry, university, government, and nonprofits. But there's over 231 partners right now, but I think what's most important for you is over 30 of them are startups. And I'll explain to you in a little while why every startup here should be involved with that activity, because it won't cost you what you think it'll cost you. So the way it works is the members of the Institute basically create a roadmap. And through that roadmap, they have RFPs for different projects, seed projects. And those projects then are determined by a committee, and then research and development is done, and intellectual property will result. And again, from that intellectual property, the goal is to have integrative and derivative solutions. And so from that, we hope manufacturing jobs. So when you think about the whole scope, you can see on the outside sort of the core applications. There's 5 of them, some aerospace, electronics, textile, composites, and automotive. And then from the cross-cutting themes, it's really looking at different aspects from cybersecurity, software, repositories, open source, et cetera. You can take a look at the ones in green there. And then you get down to the technologies itself, and they cut across all of those, everything from human-robotic interaction, verification issues, security issues, mobility issues. So these are all the different themes that eventually lead to the mission of ARM. So this was created with an $80 million grant from the government, coupled with another $173 million from its members. And that's both contributions, cash contributions, and in kind. And the projects, again, are chosen from RFPs that align with the membership, and it's member-driven. And the projects are then again selected from committee. And one thing that's very important, the IP that's generated you own if it's your IP, but everybody who's a member is able to license it at fair market value. And so that gives opportunity for disseminating the different IP. What's the value for members? Well, it's a great network, broad membership from a variety of different sources. You influence the roadmap by being a member, which leads, we hope, to have a very strong impact in terms of robotics and automation in the US. Also the notion of scale-up. Because of the people with existing operations, it's a way to help leverage scale-up. And again, it gives you an opportunity to lead and participate in a variety of products. Again, I mentioned the intellectual property, but also there's a variety of expertise that's both in the Institute and within the different members. And again, you get access to that information and also for training periodically through the Institute. So what's it going to cost? Well, for the Platinum membership, It's for large companies, clearly, $100,000 cash and then $250,000 in kind. But I highlighted what all of you who are in startups should be excited by, and that is there's no cash required to be a member, and $2,500 in kind. And what that really means is the time that you take to go to the meetings is your in-kind contribution. And it's a real opportunity for startups to then leverage and be a part of and take advantage of this opportunity. As I said, there's over 30 startups involved right now. So I'm happy to talk to you more about this. Again, I'm not leading this effort. Actually, Gary Fetter, who is now the CEO. But I'm certainly happy to get you in touch with him or others. But the other thing you can do is just go to the website and there'll be contact information. It's a very exciting initiative, again, through the leadership of Carnegie Mellon. I'm going to take one more minute to sort of change topics just for a second, because I also would like to leverage what Robbie spoke to you about and Dave mentioned. I'll just do one slide. It could take me a long time to go through this one slide, though. So I'm kidding. So we have this new exciting degree. It's called the Master of Science in Technology Ventures. And we created this degree to leverage the connection between Pittsburgh and Silicon Valley. And so the whole goal is for students to become tech entrepreneurs. It's a bi-coastal program. Students spend a semester in Pittsburgh learning world-class emerging technology and formal methods for innovation. And then they come to Silicon Valley, where they'll do an internship at a startup and then have a 2-semester curriculum on how to create ventures, be they startups or in established companies. And this is everything from the legal aspects, how to look at creating and managing a board, to how you manage people and how you manage projects and products. So it's a very exciting new program that we have. We also have an option for dual degrees. So actually for one more semester, you can get a Master of Science in Technology, for example, a Master of Science in Chemical Engineering or Mechanical Engineering, and the MSTV all in 2 years. So again, if you're interested in learning more, please come over to our table. Cheryl Root's over here. She's the program director for the MSTV program. And right now it's focused in the College of Engineering, but we're also talking to the Mellon College of Science to broaden that to larger technical areas. And with that, thank you for your time.
Bob Ryder, HEBI COO, will tell us about HEBI Robotics. HEBI was founded by my colleague, Professor Howie Choset in the School of Computer Science, who you may have seen recently on The Tonight Show with his snake robot crawling up the leg of Jimmy Fallon. Anybody see that? Nice. HEBI has participated in many of our programs as a Project Olympus Probe, as an NSF I-Core team, and in our Innovation Fellows program. So Bob Ryder earned his undergraduate degree in computer science from the University of Pittsburgh and his MBA from Tepper Business School. Prior to joining HEBI Robotics, Bob spent many years in the Pittsburgh startup community and was the co-founder of True Commerce, a software company that he helped grow to become a leading provider of business-to-business e-commerce solutions. So please welcome Bob Ryder.
Thank you, Lenore. Hello, everybody. As Lenore mentioned, my name is Bob Ryder with HEBI Robotics, and we produce Lego-like robotic building blocks. It's a platform of hardware and software that makes it easy to create custom robots quickly. And we think this is important because we see the world of robotics exploding into new areas, new potential for automation, new types of robots, new applications. We want to help accelerate this development by lowering the barriers to creating world-class robots. The technology was initially developed at the Biorobotics Lab at Carnegie Mellon, where a lot of research is done with snake robots. Now, a snake robot is a series of actuators or joints that are linked together and synchronized to interact within the environment. They are sensitive to force, and they use this force sensitivity to navigate through obstacles in the environment. But as you can well imagine, building snake robots and fixing snake robots is hard. And so researchers in the lab develop modular tools to make themselves more efficient. I said, wrong button. So what you see here is the initial modular unit that was used to make snake robots. I'll call it the snake module. So you can see the snake module up there, and you can see a snake robot created with the snake modules. But a wonderful thing happens when you enable brilliant people with cool new tools. They get creative, and so it didn't take long before the snake modules found their way into different types of robots, for example, the hexapod. And the arm that is feeding David Rawlinson his lunch, Dave's one of the co-founders at Heavy Robotics. And you may think Dave's at risk allowing a fork-wielding robotic arm to feed him his macaroni, but it's really safe because the snake modules inherited that sensitivity to force that's so important to the snake robot. The arm knows how much force it can apply so that it doesn't hurt Dave or put the fork through the table. Heavy Robotics has picked up the development of this technology, and the latest iteration is this module that I have with me here today. It has retained all of the technical goodness of the original snake module, but it's been redesigned into a different form factor. It's been redesigned to be more robust, more capable, more powerful, easier to produce so that it's more cost effective. And you can create all sorts of different types of robots with the X series. Again, I'll mention that it's sensitive to force, so it's safe. It comes in various variants, ranging in less torquey, more higher speed variants to more torquey, lower speed variants, because not every joint of your robot needs to be the same. And a really important part of the platform is the software. So the API software that Heavy has developed enables the user to control the system at a system level, but also to control the system at a joint level and gain individual joint feedback and data logging. So what we've really done is taking care of a lot of the hairy math, the heavy lifting, the technical details that go into creating a robot so that the roboticist, the creator, can focus on the more creative aspects of building a robot, the more interesting aspects of building a robot. And when that happens, all sorts of new applications and ideas come to light. We started selling this platform about a year ago, and the initial objective was to get it in the hands of end users. One of the challenges we face when dealing with a very broadly capable platform is identifying the right problems to solve. And so we said, let's get into the hands of users and see where they go with it. So we started working with universities, R&D organizations, and a handful of select industrial partners to get the modules into real use. Over the course of the past year, we've developed what I consider to be meaningful traction in the academic market. We've got a couple dozen different universities scattered around the world using our product, and that has given us excellent feedback that enables us to iterate and improve the technology, but it's also very inspiring for us to see the different types of projects that they're used in. As an example, here in Silicon Valley, NASA Ames uses the X series platform in their next generation prototype of their Super Bowl bot project. So the X series platform is helping NASA research new ways to explore other planets. Another one of our customers integrated their vision system with our platform to create a bolt-on self-driving car kit. Bolts onto an existing car and makes it self-driving. So this is important to us, this research, and seeing how our customers are using the modules. Our company tagline, and indeed our company purpose, is accelerating the future of robotics. If you look at a research project that involves robotics or hardware, the bottleneck is the hardware. One of the things they say at the lab is when you touch hardware, as soon as you touch hardware, you're adding 2 years to your thesis. So if we can reduce that bottleneck by an order of magnitude and eliminate all the tinkering with homebrewed systems and enable those researchers to create their systems in days or weeks rather than months or years, then that changes a lot of equations in research, and it does accelerate. So again, we love the academic environment, we love our university customers, but we do have our eye on industry. Our long-term vision is to enable the industrial end user with that same kind of capability. And there are a variety of different applications where this may come into play in industry. I'll focus briefly on one segment here, and that is collaborative robots. So a collaborative robot in an industrial automation context is a robot that is safe to be used by, near, around people. So a traditional industrial robot needs to be caged. It needs to be separated by a fence because it could hurt somebody. Now, when you enable that robot to work alongside the human on the factory floor or on the production line, helping each other collaborate, you open up a whole new world of automation potential. And so naturally, that segment's getting a lot of attention in the robotics world right now. We look at the entrants into this space, and they all look like scaled-down industrial robots. Look as if they're designed based on decades of expectations of working with traditional industrial robots. And we want to change the way people think about what a robot really is. So perhaps your industrial application needs 1 degree of freedom. You don't need an arm. This is your robot right here. Or perhaps you need 2 or 3 degrees of freedom. You can do that with the Heavy platform as well. Or perhaps you need 10 degrees of freedom that are not physically connected, but they're synchronized with one another to perform a task. That's something that you can also achieve with the Heavy platform. So we think it can be a game changer in that context and many others as well. And no presentation is complete without mentioning that one of the strengths at Heavy is the team. So Professor Chozit at CMU has done a great job of establishing a world-class team of engineers. I am very pleased to be able to work with them each day and very thankful for it. And I invite you to check out our website. It's heavyrobotics.com. And also, I want to note that we have a YouTube channel with a variety of demo systems showing off what we can do with the platform and what some of our customers are doing also. So please check that out. Also, it's YouTube/heavyrobotics. Thank you.
Now I'd like to welcome Tom Galuzzo. Tom, where are you? Who is Chief Executive Officer and founder of IEARN Robotics. Tom has over 17 years of experience in autonomous robotics, working with Carnegie Mellon and in industry. Tom has developed autonomous systems to compete in the International Intelligent Ground Vehicle Competition and the DARPA Ground Challenge. Tom has a PhD in robotics and a bachelor's in aerospace engineering. Welcome, Tom.
So yeah, thank you so much to Dave and Lenore and Craig and everyone at the Center for Entrepreneurship at CMU. We are absolutely honored to be a part of this and to be bringing the great work that we're doing in Pittsburgh in robotics to the rest of the world. So my name is Tom Galuzzo. I'm the founder and CEO of IEARN Robotics. Our company does warehousing and manufacturing automation with robots. So I'd like to introduce you to Swift. Swift is the world's first industrial mobile piece-picking robot. This is Swift working at our first customer site in Rochester, New York, Rochester Drug Cooperative. The robot is picking goods at a rate of about 100 to 150 items an hour for distribution to mom and pop pharmacies around the Northeast. So the whole idea here is we have robots that are able to navigate around a warehouse to find items using computer vision. IEARN Robotics has developed the computer vision technology that allows them to navigate and see items. And so we can have our robots aggregate goods in the facility to bring those goods over to pack workers, pack and ship workers, so that people don't have to do the unproductive walking and material handling. The robots do that for them. And this can save a business upwards of 50% of their operational budget. And so there's a significant cost savings in being able to drive the economics of using robots and automation to aggregate goods in the warehouse. So what the robot does is basically just uses its cameras on board to navigate around. We have a map of where all the items are and a memory of what they all look like. The robot grabs them and picks them. All of this is driven by our software. So our software is called Swift Link. This is the software that connects the warehouse management system up to a network of Swift robots that will operate at our customer site. So this is everything that the customer needs to set up, command, control, configure, track the robots, and monitor their performance and make sure that they're all working as expected. Of course, things aren't perfect in the warehouse. When anything goes wrong, a person with a mobile device will get a notification through SwiftLink that says, hey, the robot's having some trouble finding an item, or something's out of stock, or what would you like to do? Would you like to wait? Would you like to continue? And those are the kind of options that we offer as part of this SwiftLink software. We also have other applications that we're working on beyond the simple piece-picking applications. So if anything is too small or too big for the robot to grab directly, then we can put those items in a box, and then the robots can go retrieve those boxes. Warehouse workers walk up to 60 to 90% of their time, and all of that time is paid for by our customers. So anything you can do to eliminate that unproductive travel time is very convenient. Of course, this is very similar to what Amazon does with their acquisition of Pkwy Systems in 2012 for $750 million. But Pkwy Systems just brings over a whole shelf of product, and what we're doing with Swift here is just retrieving the individual goods or the bin that has the specific product that you need. That's the difference. We also have a new stealth application in manufacturing. The customer here is the largest manufacturer in the world in their particular market, and they bring a customer lifetime value to our company in the range of $20 to $50 million. So we have an initial contract with them this year to start to develop the software. It's a $650,000 contract. Over the next 4 years, we have about $8 to $10 million budgeted to go to IEARN Robotics for installing a set of robots for their particular application. So the key question here is, why robots? What's the difference from classic automation? Because everyone's wanted to save money in business for the past 1,000 years. Why is it robots now? And this is the reason. They're out of labor, believe it or not. So if you do the math at a macroeconomic level, Americans spend 40 billion hours a year picking and shopping for consumer goods. To drive all that via e-commerce would take over 20 million full-time jobs the way that they currently do warehousing in the e-commerce industry. And that is absolutely more people than we have in the entire US unemployment pool. So we've been told by major executives that they can't find and keep enough people in this job. So we believe that robots that can work alongside people and work in the warehouse in this kind of manner that's interchangeable with manual labor is absolutely the way to sustain the baseline growth of e-commerce and the growth of manufacturing in the United States. A little bit about our business model. So we essentially sell robots as a service, and what that means is that we lease our robots for about $50,000 a year to our customers, and that includes all the support and maintenance and software upgrades that they need to continue to sustain their robots and grow their business. We're a little bit unique in the way we do this in that we use a financing partner, so that IEARN Robotics doesn't have to fund these expensive robots if we get a large order to scale. So our financing partner is AmeriCorp Financial. They finance medical equipment to the healthcare industry, and they got involved in this market through their work at Aethon, which is another Pittsburgh robotics company that does hospital robots that drive and move goods around hospitals. So they see this as a growth area for financing this kind of equipment, and allows our customers to scale faster without having a significant capital expense on purchasing robots. They can pay for them monthly and get a faster return on investment. So of course, all this is enabled by our team. Vlad and myself come from NREC, which is Carnegie Mellon's National Robotics Engineering Center. It's where a lot of the robotics commercialization work, a lot of the early driverless cars work that was done for the DARPA Urban Challenge, the DARPA Robotics Challenge. Some of you may have seen our chimp robot and so forth. That was all from CMU. And that was all from the National Robotics Engineering Center, which we were a part of. John Cameron is an expert in machine vision and perception. I worked with him at Harris Corporation doing classified robotics. Steve Brown comes from Philips Respironics and has a strong background in robotics and automation and in manufacturing. And Andrew Wells is our newly minted MBA from Pitt. Yes, we do work with Pitt people from time to time at CMU. So he's helping us with sales and marketing, and he's doing a great job. So our next steps for our company is Series A financing. We're going after at least $10 million this year to help us scale sales and marketing and manufacturing of our robots around our core team. Of course, we're looking at acquiring these new customers and new applications. We're scaling our deployments and refining our product in the process to make it better and better. So I hope you enjoyed meeting Swift today. Please get in touch with me if you're interested in learning more about IEARN Robotics. Very easy to reach, just tom@iamrobotics.com. I'd love to talk with you more in detail about what we're doing. Again, I am Tom Galuzzo, and that's IEARN Robotics. Thank you very much.
Thanks, Tom. I think you're getting the idea why the Wall Street Journal has called Pittsburgh Roboburg. So for another robot company, I'd like to introduce Steve D'Antonio, who is the Chief Operating Officer of Carnegie Robotics. Steve was one of the original founders of Carnegie Robotics as CEO. Steve has directed the company into new commercial markets and expanded internal product development. Prior to joining Carnegie Robotics, Steve was Business Development Director of what you just heard, the National Robotics Engineering Center at Carnegie Mellon. He has an engineering degree from Lehigh University and an MBA from Harvard, so we actually also recruit from Harvard as well. Okay, Steve?
Hi, good afternoon. Steve D'Antonio, CEO at Carnegie Robotics. Hopefully I can get this video to play. No. Yeah. There we go. Okay, so that's a commercial floor scrubber. We're collaborating with Nilfisk, which is a Danish $2 billion commercial floor cleaning company. And in this case, we develop all the software for this, have developed the autonomy kit, and then we're now going to convert this relationship from an engineering relationship to a product supplier. So this was at the ISSA show in Chicago in the fall. This product will go to market this summer, and then we're beginning the automation of other parts of their product line. So they started to get lots of demand for this kind of capability. Just wanted to give you a sense for what's new. So the company itself, we're a 75-person company, a spin out of NREC, same as Tom's company previously that we talked about. And we are an engineering company as well as manufacturer of robotic systems and components. And those are the markets that we go after, and I'll give you some examples as we go forward. So lots of people have been saying robotics is the next big thing, and so let me take a shot at that. In fact, I think this grows and maybe backs up some of the earlier speakers. So that title out of the Wall Street Journal got my attention because in the last 2 decades, really the productivity growth, which really dictates cost of living or cost of quality moving forward, in the physical industries has really been lacking. Compare that to IT, where it's been very strong. In industries like agriculture, construction, mining, it's really been lagging. You're not going to solve that problem with people. We're already at full employment. I know at our company we're having trouble bringing in assembly people, and I've heard about, of course, many other manufacturers in the same boat. What I've also noticed is, of course, with the driverless car investment in the billions, for the first time I'm seeing CEOs in industries outside of that who are really concerned now, hey, is my product line going to get disrupted? And they're starting to spend some real money to do new forms of automation of the product line. There's plenty of research out there. I worked for CMU for 16 years. There's plenty, and it's really ready to be commercialized. And the other evidence is now at CMU alone, they've started master's programs in robotics and are graduating 80 to 100 per year. We hire lots of those. And they're not going to be researchers, they're really going to be practitioners of the art and apply it for real systems. And then finally, in the cell phones and Internet of Things, there's all kinds of low-cost processors, IMUs, cameras, and sensors that when you creatively bring them together, you can really make some interesting capabilities. So that's the case. So what's some of the problem? And I think it really gets to a lot of what the gentleman from Heavy talked about is robots are expensive to develop. I think part of the problem is that there's really no first-tier supplier base available for this because it's really robots is an integrative science, right? They, particularly in a ground robot, they all share common components. You need to see the environment, a perception system. You need to know where you are in the world, a positioning system. You need to be safe, not hurt itself or others. And then you need a computer to run all this software. So that's generally a capability that you need across all the different types of platforms. But there really isn't a series of component suppliers yet because it's really been an emerging market. And really, if you wanted to be a component supplier, if you wanted to start investing your own money, the number one question is, hey, is there enough volume for me to sell this to system developers? And really, what should I build? What is the right requirement? What's the sweet spot to meet all these applications? And on the system developer side, so all these folks that are showing you mobile robots moving around, it's really a make versus buy, like any system developer. And on the buy side, it's like, are there components there? Do they perform? Are they affordable? Can I integrate them? And what often is the case today is the answer is no. So they're going to make their own, or they're going to adapt a sensor or a component made for another market and try to adapt it. And as a result, you end up spending a lot more money and time to get that robot built. You may never get to market. And the other key thing is that you really get to divert it from maybe what your core differentiator of what your robot application is. And you really, if you have to build everything from scratch, then you need a holy triad of mechanical engineers, electrical engineers, software engineers to build a robot together. And it'd be great to be able to just get the type of engineers on your core IP. Okay, so what's our strategy? So we do custom system development. And so we've served various markets. So the one up on the top left is a robot that detects IEDs, and the Army will be making a production decision on that in January of 2018. And then, of course, there's the Milfis robot. Both of these share a common component, in this case, a stereo camera that provides obstacle detection for their various applications. So that's our approach, is we look at across the markets, and are there some common requirements? And if we think there's enough volume there, we'll spend our own money, and we'll partner, and we'll license technology, and we'll build components. So we've done it in the stereo camera area as well as in positioning systems. And then we sort of build our own little market by designing them in, and as these things go to market, we start to build volume. So let's expand a little bit in the stereo cameras. We've had a line of stereo cameras since 2012. And some of the pictures there show what some of the data that they produce. The upper one there, we have a partnership with Mind Vision Systems, and they use our stereo cameras to basically look at the convergence of the mind. Is it changing? Where do I have to put roof support? And there's literally thousands of mines, underground mines, that need this capability, and this company is starting to scale up, and they're using their sensors to get there. The lower one is a manhole, where you want to do inspection of, does this manhole need to be repaired, enhanced in some fashion? And all of these are not images. These are colorized point clouds that come out of the stereo camera. Then in the positioning side, we have a partnership with Swift Navigation up in San Francisco. They're a VC-funded startup that has great low-cost GPS RTK technology. And then we've went ahead and developed an enclosure for them to make it very easy to integrate this capability into ground robots. We'll be bringing a lot of our positioning software in to make this we think, a very enabling technology for ground robotics at a price point that really can't be matched. Okay, company outlook. So we're right now about a $15 million company. We've bootstrapped it. We still have the original capital from the 10 founders back in 2010. We're at the stage, and one of the things we're doing right now, it's going to be finished in another month or so, is we're building a production facility to handle the expanding product volume in the company. That's the fastest growing part of the company. At this point, we really have a proven team that knows how to engineer and build things and be able to meet a price point. And believe me, it took a long time to get to that. It's very hard. But we've got new systems and components that are going to launch this year and next, and we're looking to raise about $5 to $10 million in the near term. Use of funds. So we've really been, we haven't focused a lot on marketing and sales. We've never actually had one of those types of employees. I have nothing against those people. I used to be one. But we really focused on, let's figure out how to make this work. Let's figure out how to engineer. Let's figure out how to build. And now we think there's the opportunity to really grow the company rapidly and expand this notion of components into more parts of the anatomy of a mobile robot. So again, my name is Steve D'Antonio. Please see me after the talk if you're interested in learning more. Thank you.
Okay, it's my pleasure to introduce Damien Shelton. Damien? Oh, there you are, good. He's the CEO and co-founder of Agility Robotics. Damien joined Agility Robotics as CEO in early 2016, initially focusing on the tech transfer and seed funding efforts. He is currently focused on building out the sales and manufacturing capabilities of Agility's first product, Casey. Prior to joining Agility, he was co-founder and CTO of Three Rivers 3D, where he led the technical development effort that resulted in a commercially successful line of low-cost 3D scanners. Welcome, Damien.
Okay, well, good afternoon. I'm excited to present Agility Robotics. We build a dynamic robot called Cassie. Our vision is that robots have a lot of interesting things to do outside of constrained environments. And by that I mean environments that were designed for people and not for machines. It's been possible to automate lots of tasks for many years if your environment is designed for the machine. And our assumption is that there are lots of other things that you can do. I have a couple of examples of these for things that require you to be able to operate in a human environment. And we think that our approach is more versatile than existing methods of outdoor operation. That would include wheels, tracks, and wings. So good examples of tracked vehicles are like iRobot's Pkwy. There are a lot of aerial drones now that would fall under the general wings category. And Cassie, shown here, is our first product. To answer our most common YouTube question, no, this is not a render, this is an actual robot. Cassie's about yay high. And I'll show you a video of Cassie now, and this does have sound on it. Okay, so that's Cassie. One reason why I got really interested in this about a year and a half ago, and I'll give you a little bit of backstory on the company later, was looking at the recent interest in last mile delivery. There are two general classes of solution that have been proposed to this. The first is wheeled vehicles, and I'm not trying to pick on Starship Technologies, because they've done some amazing work. But wheeled vehicles have limitations. You can't easily climb stairs. For delivery applications where you have to reach a counter or do material handling, it's challenging because you end up with a robot arm kind of mounted on top of a wheeled vehicle and the center of gravity isn't ideal. More importantly, from our perspective, is that crossing uneven terrain can really be a challenge. So, a lot of delivery environments are not well-structured factory environments. They're outdoors with things like toys in front yards and so on. Aerial drones like the Amazon Prime Air device have a limited flight time. I don't know about you, I'm not excited about ordering some dog food from Costco and having it flying in the sky at 100 miles an hour above my house. The FAA also turns out has something to say about that, so the regulatory environment has been a little bit hostile. These are classic Pittsburgh pictures, which are our high quality infrastructure supported by our enormous tax base, and then houses that have very interesting access. And there are lots of areas in the country that are like this. San Francisco is an old city too. There's lots of places that are only really accessible by people that we don't really think about unless we're confined to a wheelchair as a result of an injury or a disability. So our philosophy is actually to focus on dynamic behavior as opposed to trying to match a specific behavior programmatically. And I have a high-tech demo. So I'm a roboticist by training. I've decided to invent a clock. And the way I've decided to do this is to attach this phone charger to a cord. And my idea is that every time it swings back and forth, I'll count it, and that's going to be my clock. So as a roboticist, I put a 1 kilohertz control loop up here with a sensor and a really nice low inertia actuator. And then I have a computer sense it and say, okay, I'm going to make the thing move back and forth. And here's my clock. Now, obviously, the easier way to do this is just let it go and swing back and forth. In this case, physics is driving the system. And an interesting characteristic of this clock is that if I whack it, it comes back to its timekeeping. So there's no sensing going on with this. I'm not actively controlling it. And I can recover from disturbances and add energy to the system with it behaving based on physics rather than based on computer programming. Our saying is that you can't program a rock to fly even if you have really, really great code. So that was demonstrated with this robot Atreus here at the DARPA Robotics Challenge a couple of years ago. And it was a really great science demonstration, but was not such a great product. If it fell over, it would have broken, and that would have been the end of Atreus. So that was the motivation for Cassie. Cassie is power efficient. We have between 8 and 10 hours of battery life for mixed standing and walking, which is longer than it takes to walk up to somebody's front door. We have about a 10-kilometer range at a 5-kilometer-per-hour operating speed. Cassie was designed to fall on its face, so the carbon fiber face of Cassie has already hit the pavement at walking speeds. And it's human scale, safe to be around. It's about 30 kilograms. Mikhail, shown here, is one of our co-founders. I can't easily lift Cassie, but Mikhail works out more than I do, and he can load it in the cars just fine. Our go-to-market strategy is to sort of climb a ladder to verticals. We considered whether we wanted to stay as a stealth startup and develop the technology in the backside of the company and have a very minimal public exposure. Decided that the way to do this was actually to treat this as a mature product from the get-go and take our lumps on the manufacturing side. So looking out, a couple of years, by the end of 2019, we want to be doing sort of iRobot, PackBot performance, 50 to 150 units a year. We're already at our sales target for this year, which was 5 units, and growing slowly. So these are all proven companies: Mecha, Boston Dynamics, iRobot, and then hypothetical FedEx bot from the Will Smith iRobot movie. The interesting thing with the logistics market is how large it is. It's a $35 billion a year labor market just in the US, and that's only labor that's associated with curb to doorstep delivery. That's not any of the back end logistics on the supply chain. That's what it costs to get packages from a UPS or a FedEx truck up to your front door. So where are we now? We've sold 3 Cassie 1.1s. We're going to be delivering those in June this year. We have better than 50% gross margin in quantity 1. 8 employees, 6 of whom are full-time. We're funded through mid-2018 on a mix of seed funding and profits from sales, and targeting our Series A for this summer so that we can expand. So I founded the company with Jonathan Hurst, who's also a CMU grad. Both of us started in 2001, and I've known him the entire time. So we go back 16 years. Mikhail Jones was one of his first students, was responsible for getting Atreus working. So basically a team of the smartest PhDs in the world tried to get Atreus working for the DARPA Robotics Challenge, and Mikhail came along, drank a bunch of coffee, and got Atreus working sort of single-handedly with a master's degree. So I refused to let him get a PhD, grabbed him and stuffed him in the company, and now he's working with us. We have a worldwide exclusive license to the technology underlying Cassie. We have a 5,000 square foot facility in Albany, Oregon. I'm actually based in Pittsburgh. We're hoping to start a Pittsburgh office to do more computer sciencey things as we move forwards. And our first customers are academic customers that are going to allow us to both gain experience with field deployments and also curate a hiring pool. There's not a lot of people available to hire who are legged robotics experts out there, so we'd like to own all of them. Moving forwards, we like to think of Cassie as the Model T of bipeds. If you ask people what the first car was, they'll say it's the Model T. Of course, it was not the Model T. There were cars close to 100 years ago, or 100 years prior to the Model T. But we think that we have one of the first bipeds that's designed for low-cost production, has a clear path to getting out there to be used and abused in the real world. And Cassie is an evolving platform. We're focusing on products, not demos. So we don't do demos. We only sell Cassie robots, and hopefully you'll see one delivering a package to you in 3 to 5 years. Thanks.
So last but not least, it's a great pleasure to introduce Austin Webb, who is the Chief Executive Officer and co-founder of Robotni. Robotni developed their first indoor vertical farm prototype in our Project Olympus incubator. And if you came by, you would have seen this glowing lilac colors in the window there. It looked like kind of a big event always happening. They are now selling at Whole Foods, and I can attest that their arugula is delicious. You should go out and buy it. They have received many awards. The recent one was first place at a regional Clean Tech Up competition, and they will compete in the national competition in June, sponsored by the DOE. Austin is the CEO and co-founder of Robotni, a robotic indoor vertical farming company based in Pittsburgh. Concurrently, Austin is also obtaining his MBA at Carnegie Mellon's Tepper School of Business with a focus on entrepreneurship, technology, and strategy. Before starting in Robotni, Austin served as financial analyst at Lockheed Martin and then as investment banking associate for FBR Capital Markets. Austin originally hails from Chapel Hill, North Carolina, but plans on keeping roots in Pittsburgh to achieve Robotni's vision and mission. Great. An avid philanthropist for food security, he's excited to be solving the future of agriculture. Welcome.
Good afternoon, everyone. It's a pleasure to be here today. Again, as Lenore said, my name is Austin Webb, CEO and co-founder of Robotni. Just graduated this past weekend from Tepper School of Business, but actually been full-time on this the whole time for year 2. So pretty great what you can do at CMU in terms of taking school and turning it into more of actually working at your business. But again, we're a robotic indoor vertical farming company. So we're using robots to manufacture things as well, but we're manufacturing or really growing living organisms, right? Plants. And so we are using automated robotics and software analytics to transform agriculture. So not just redefine the vertical farming process, but also change the way we look at agriculture today and solve many of the environmental problems that are associated with that. And so to hit on that a little bit further, right? Traditional ag today, the process is broken. It's the #1 pollutant of water on this planet, the #2 pollutant of air. It uses over 70% of our water source, which is less than 1% on the planet. And the supply chain is broken. So today, what you are getting on your plate are issues with food quality and food safety. And this will only increase as the dynamics continue to change, and that we have 7 billion people on the planet today, estimated to be 10 billion by 2050, with 80% of those folks living in urban cities, right? So this is a really huge problem and something that's near and dear to us, and a big reason why we believe in vertical farming. Vertical farming allows you to grow plants indoors. You can put them on shelves, stack them on top of one another, get superior density, control the environment 24/7, 365. At Robotni, we use 95% less water than traditional ag, and we use no herbicides or pesticides ever, and so that means we have no runoff pollution. We also use no topsoil degradation. We are soilless growers. And the big thing is that vertical farming has gotten a lot of press over the last couple of years, but the one thing that these outlets really aren't discussing, including what was just in New York Times and Wall Street Journal this past week actually, is that vertical farms are really inefficient, and they are not manufacturing operations that we would like to see today and that we see in other areas of the world and other industries. And so, very manual, labor-intensive processes. Folks are walking and running into each other, grabbing plant trays with ladders and scissor lifts one by one. Labor is actually the same amount of their operating expenses as the energy cost to actually have all the LEDs and the HVAC controls for the environment. And then on top of that, they waste over half their production space. And as you can see in the picture, right, using pen and paper and clipboard. And that's great when you're in a meeting and you really don't have time to take notes, but why would you do that when you have hundreds and hundreds of trays and you can have a fully integrated solution that works at optimum ability? And so Robotni, what we've done is created a fully integrated solution of robotic hardware and robotic software. All right, and so on the hardware side, we've essentially created an autonomous storage and retrieval system that works in the indoor vertical farming space. And this means that we can create pure human-free grow rooms. This means that we can pump additional CO2 into those rooms for more robust growth. It means labor efficiencies and space efficiencies, as we no longer need wide aisleways. We no longer need ladders and scissor lifts. We bring trays of plants to automated stations, to workers for a much better process. And it's fully integrated with our software, and that our software is the central brain of this system. Controls the robots, controls every sensor and actuator that we have throughout the farm. And so we can monitor the farm 24/7, 365, and do things where our pH levels, we have a range for what the perfect pH should be for any plant that we grow. And if it starts to get outside of that range in the fertigation tank, right, our system sees that and automatically fixes that. But on top of that, we're able to take every single one of those environmental parameters, from light spectrum to the light schedules, nutrient mix, nutrient schedules, relative humidity, pH levels, right, all of those, and we can create optimal grow recipes for every single plant that we grow, and we can focus on really important things like nutrients and taste, or the ability for shorter life cycle or more yield per plant, per leaf, as opposed to what's been happening in traditional ag for a long time, which is trying to optimize for plants' ability to handle Roundup and other pesticides. And so I do have a video of our version 1 miniature farm. So we've actually got a version 2 of this now, but filing a patent tomorrow. So simply showing the version 1 at this time. You'll see the real thing in a minute. But we're able to grab plant trays, move them to different environmental parameters on different shelves, put it onto a track system, and again, put those trays to automated stations for harvesting, for sanitation, et cetera, as opposed to workers going up on wobbly scissor lifts. Right, so all, automatic nutrient mixing, automatic light control. We do aeroponics, which means we have a nutrient-rich spray to the roots, and we can do everything we're growing to date, such as leafy greens and herbs. All of that we're doing 2 to 3 times faster than in a traditional setting, it's just really fascinating when you just sort of think about how we've been growing for a long time, and to simply change that in a new method, in a new way, so that you can get 180 times yield per 2D square foot, for example, and you can do things year-round in the middle of urban cities, and therefore cut down on food mileage waste, and solve last-mile problems, and Robotni, getting with Cassie and being able to deliver to your door, right? Things like that that we never thought of before. And so, just to put this in perspective, what all this means is, we're the only company in this space that's created a fully integrated solution of, thinking of data analytics and automation simultaneously. We're not stuck in sort of the one-off incremental band-aids that a lot of our other competitors are stuck in. And we really, approach this with what should the perfect, take a blank warehouse and what should the perfect process be? And then again, 180 times yields per 2D square foot is what we're currently doing to date. And we're doing that with higher margins than other vertical farms, than greenhouses, and local organic outdoor farms, big or small, throughout the country, and a lot of which are here in California. And that's all great, and you're probably wondering, what does this mean for me? Well, what it means for you is pure, beyond organic produce that's herbicide, pesticide free, and being able to eat it the same day it was picked or the day after, instead of it taking 5 to 21 days to get to you. And you're not the only person out there at every generation looking to avoid chemicals, and it's all about fresh, local, healthy food. And that's something that Robotni is able to do with our technology. And so, because it's a small market and there's only a few players, we've actually created a new operational playbook. We are leveraging our own technology, as I said, to provide this beyond organic produce. And it will allow us to get to scale faster, right? And also create a market. And so, not just owning and operating these farms, but potentially franchising these farms, which we certainly got a lot of interest to date. That's what we're looking to do, right? And what that looks like, right, is the brand that we've created to date in Pittsburgh, in Whole Foods, is Pure Sky Farms, right? And that has, every connotation I mentioned earlier. Had a really great launch. We're definitely got a lot of partners who are interested in working with us beyond Whole Foods. But we're looking to take that beyond Pittsburgh, right? So launching a full-scale farm later this year is the plan in our new facility that we are now in the south side of Pittsburgh. And then looking to cookie-cutter model that and put these farms in every city in North America and then the world. And at that point, you no longer have the same supply chain issues you had before. You've inevitably solved it purely by co-location. And then in addition to that, diversifying crops, doing more than just leafy greens and herbs. You can't feed the world on just lettuce. So things like strawberries, and then medicinal plants to solve a number of diseases from malaria, et cetera. The same reasons why we have a perfect, pure environment, as we call it, beyond organic environment for produce, also means a pharmaceutical grade environment for medicinal plants, right? And so looking to hopefully have 20 farms by 2022 or more, and again, look to expand into other areas of the world. And so where we're at today is last year when I spoke at this event, We had not built a single thing, so everything was in theory. And we've built our first version 1 prototype that you saw in the video. We've raised a little over $700,000 in venture capital to date. We're building our version 2 prototype now, about to turn that on. It'll do 40 pounds per day, and it's a miniature version, if you will. It's at scale, but it's 2,000 square feet versus the 20,000 square feet that we look to build, and we're in the process of raising a $10 million Series A right now. And so that's where we're at in Pittsburgh, again, to prep for this large farm that we look to launch later this year. And so our team, just to end it, I usually go into more detail, but I'll just at a high level say, these are some of the smartest engineers I've ever worked with. Together, we do the business, the robotics, the operations, and the software experience to get this done. We come from blueberry farms, we come from vegetable farms, and so while we are techies, we are also very much green, have green thumbs, and that's something I think can be validated by Whole Foods. And so with that, I really appreciate your time. If you're interested in speaking more, I'm in the back corner here on the right side of the room. And so, look, vertical farming is the future. And Robotni is the future of vertical farming. Thank you so much.
Well, as you can see, we have some school stuff happening at Carnegie Mellon. And so all of the 5 presenting companies plus 30 total companies are here today. We have the next hour and a half. Can you believe we did it on time? Wow. That's pretty amazing. We have the next 90 minutes. We do have to clear the room at 6. We have the next 90 minutes to network. There's a lot of great food in the back and drink, so please partake. One last thank you to our sponsors, Oracle and Latham & Watkins. Thank you very much. Yeah, absolutely. We could not do this without them. Every good entrepreneur always has an ask, and I had mine earlier, but I'm going to repeat it. Everybody in this room should be a customer, a supplier, a mentor, or an investor, and I'm going to add one more, or donating to Carnegie Mellon so that we can continue this momentum, all right? Really appreciate that. We have a lot of people in the audience here who have donated, so we really appreciate it, but we're creating a pipeline that's going to change the future, and you're all a part of it. So thank you all very much for coming, and have a great day.